Hello, my name is John Calloway. I am the host of the Calloway Conversation podcast. Over the past few years during my college career, I've run into some really interesting people, and I thought that these people should have a spotlight on the internet. So I created this podcast, and I am honored to have Dr. George Vellidis as my first guest on this podcast. Dr. Vellidis is a leading expert in precision ag at UGA, and he's also the founding and director of the Institute for the Integrated Precision Ag Program. Thank you for joining us, and would you mind introducing yourself just a little bit more?
Yeah, well, first of all, thank you for inviting me to this inaugural episode. I think it's going to be a very successful podcast that you're initiating. My name, as you said, is George Vellidis. I'm a faculty member at the University of Georgia. I've been at UGA for 36 years, and I've been working in the area of precision ag since, I would say, 1995 or so. And it's really interesting how we got into precision ag. It all began with two graduate students about 1994, 1995. They were both in the crop and soil sciences department, and one of them was interested in measuring the spatial variability of soils in fields. So how we went in one field from, let's say, a sandy soil to a clay soil. He wanted to be able to map that and understand how it affected yields. And the other student wanted to be able to actually measure the yields so that they could create maps of how yield differed across the field. And because of these two students, we started a precision ag program that's been going strong for over 30 years.
That's amazing. That's super cool. So the first question I have here is, what gave you, kind of going back to how you got started, what gave you the passion for agriculture when you were younger, and then how did that lead to where you got to here today?
Yeah, good question. So my background in terms of training is in agricultural engineering.
Okay.
When I was maybe 10 or 11 years old, I read in a magazine about how agricultural engineers were trying to convert the sand dunes of the Sahara Desert in Libya into agricultural land. And it just fascinated me, the application of technology and engineering science to do that, as well as agronomy. So I thought, well, that's what I want to do. I want to be an agricultural engineer. And that stuck in my head, and I pursued it, and have not regretted that decision.
Wow, that's awesome. Would you mind explaining to the viewers where you're from and how did you end up at Tifton, on the Tifton campus?
Yeah, so a little bit of a long story. My background is Greek, so I was raised in Greece, and I wanted to study agricultural engineering, as I mentioned. In Greece at the time, and still today, there wasn't a thing called agricultural engineering at the universities there. Okay. They have something that's called engineering agronomy, which is not exactly the same thing, but agricultural engineering is you get trained as an engineer, just like a civil engineer, mechanical engineer, except you specialize in agricultural applications. So I decided, my parents fortunately could send me to the U.S. to study, so I came to the U.S. and studied, and then I decided to stick around for a master's degree and a PhD. And while I was completing my doctoral work, I started applying for jobs, and there was this great job open at the University of Georgia at the Tifton campus. I applied for it. I was lucky enough to be selected for the job, and here I am.
Awesome. That's amazing. That is a very cool start to your career. So back to the precision ag topic, can you explain for people who may not be involved in agriculture what the topic of precision ag is and how it is used in agricultural production? Kind of like a brief overview.
Yeah, let's see. So I think the best way to start is to describe why we may need precision ag. So if you look at a farm field, doesn't matter really where you are in the world, and you sort of have some elevation, so you look down at the field when the soil is bare, you'll see patterns of color. You'll see darker soils, lighter colored soils, orangey soils, reddish soils. That indicates different patterns of soil type. Okay, different soil types have soil textures that are different, which means their ability to hold water and to grow plants differs. They have different nutrition levels. And when your great-grandparents may have farmed, or when my grandparents farmed, they farmed behind a mule, and they walked every foot of their land, and they understood these differences. And if they had manure from animals, they knew to spread it where they thought it needed it the most. But as we went into the middle of the 20th century and we started using larger and larger farm equipment, we lost the ability to address these individual parts of the field to meet their needs because we were farming on a large scale. And so when things like GPS became available, that allowed us again to start creating maps of these differences in the field and being able to develop equipment that would allow us to, let's say, put different rates of fertilizer on part A of the field that was less fertile and a little bit less on part B of the field that was more fertile. In other words, we were balancing the inputs, which are water, fertilizer, and amount of seed, to the part of the land that needed it in those amounts to optimize our production efficiency. So just think about if you're a farmer and you've got this field that's got sand on one side, clay on the other, and you're putting on the same amount of fertilizer everywhere, you're probably over fertilizing the sandy spot because it's not really going to grow much food anyway. And then you're under fertilizing the clay area where you might have much higher yield production. So if you adjusted where you applied your fertilizer amounts, you would increase your efficiency and probably your yields.
Right. So everything in your thought process would be decreasing cost and maximizing productivity.
Yeah, I think for precision ag, what we need to focus on is maximizing efficiency and profitability, and not necessarily putting on more inputs to increase yields, which may lead to reduced economic profitability.
That's a big deal right now in agriculture with people struggling to support what they're in debt to. So having the max profitability from a production standpoint is very important.
Yeah, and I have, if you let me follow up there. So, we've developed technologies now that allow us to measure yields in the field. So we have sensors we can put on machines, the harvesting machines, and as they go through the field, they measure the yield. And with our GPS, we can create data points that have coordinates and yield. We can make those into maps. So we can see where the yield is higher and lower. We can also use economics to understand how much money we're earning or losing in parts of the field. So if we're farming a field conventionally and applying the same amount of inputs, seed, fertilizer, water everywhere, we can see pretty often in most fields in Georgia, especially, but all around the world, that there are parts of the field that we farm that we're losing money in. So we would actually be better off using the conventional approach not to farm those pieces of the field because they cost us money. But in precision ag, what we figure out what to do is how to make those parts of the field cost effective. So we're not talking about taking land out of production, but figuring out how to manage the profitability on different parcels of land.
Wow, that's amazing to hear that there's such a big initiative to help farmers out in that way. And so before we talked, you had mentioned the creation of the Institution of Precision Ag and here at UGA. Could you explain what the Institute will cover and how it will work as far as its relation with the school and what you might be able to learn with pursuing that career?
Yeah. So let's go back 3 or 4 years. UGA did a study using stakeholders all around the state of Georgia to understand where the university should invest resources in terms of adding new faculty and research monies in order to positively affect Georgia's economy, particularly in technology. And since agriculture is Georgia's biggest business, ag tech was really one of the first things that popped up. So what UGA did was invest in hiring 12 new faculty who work in this area of precision ag. So these are people whose traditional backgrounds are either in engineering, in agronomy, entomology, food science, whatever, all over the spectrum, but they're now focusing on precision ag. So we have 12 to 15 new faculty members at UGA focused on precision ag. And the Institute was formed to ensure that we have an umbrella organization under which all these new hires, plus all the people who are already at UGA that can contribute to precision ag, can work together. In other words, an umbrella organization for precision ag to help build teams, to help people address the big challenges that we have in agriculture today.
Would you say there's a particular career path right now that can help agriculture that those people in that career may not understand that they could. So, as far as like somebody within the tech world, what is the technical inputs that we could use in ag that those people may
Yeah,
not know
that's a really such a great question because let's take robotics for example. So agriculture in the U.S. is really struggling from the labor perspective, right? We don't have enough people on the farm to do all the labor that's needed, and a lot of this labor is very difficult to do, like picking strawberries or harvesting apples. It's really difficult manual labor, and we don't have the people who want to do that labor. So robotics could be a way for us to be able to develop machines that harvest apples or harvest strawberries or do all many other manual labor tasks. So back to your question, we have someone who specializes in mechanical engineering, who's building robots to assemble cars in a factory. Okay, we could take this person's knowledge and skills and apply them to solving agricultural problems. So that's what we hope to do in the Institute of Precision Ag. We've got those of us on the ag side who understand the ag problems. We want to work together with the people on the technology side who don't work in the ag space and entice them to come and work with us to solve these big problems.
Wow, that's amazing because that really opens the door to other people who aren't involved. And some people want to be involved in ag, but they didn't pursue it because they may not have seen the financial side of it as it being productive after school or.
I don't necessarily think it's the way you expressed it. I think it could be that just people have different backgrounds. They have different focus for their research and for their applications. And so, like if you've been trained to be a mechanical engineer to work on automotive, that's what you've been doing, and you just may not have realized that there's opportunity elsewhere to apply your skills.
Wow, that's super cool to hear that there's other avenues for those people to take. So we've already mentioned robotics within ag developments. What are some ag developments currently that we're developing here in the U.S. or in other places that could be changing the whole aspect of agriculture?
Yeah. Well, of course, I think AI comes to everybody's mind about how it's a technology that can affect everything we do in our lives. And I think in precision agriculture, it's particularly relevant because we have developed a lot of sensors over the last 30 years, which help us collect data about what's going on in a field.
Right.
And we're accumulating piles of data that we can't really sift through using our conventional statistical techniques or our current statistical models. These are data that can help us understand why, how we can make this part of the field more efficient. What does it need to make it better? With AI models, we have now computer programs that have been designed specifically to use all kinds of large data sets, analyze them, and be able to find the trends inside those data that help us make better decisions. Wow. So it's advanced computer chips and tailored software that helps us make better decisions. And what's novel about it is just that it's the new capability rather than a huge breakthrough in computer technology or something like that. It's just the next step in my mind.
So you mentioned the creation of GPS. How many years ago was a GPS created? About 20?
No, it's much more
longer?
than 20. In the 1980s, actually, the
Okay.
U.S. Defense Department and also the Soviet Union's defense group started building global navigation satellite systems that would be used for defense purposes. But by the late 1990s, civilian uses of these systems had expanded so much that it became common use all around the world. Yeah, so GPS is actually the acronym for the American Global Navigation Satellite System.
So in 30 years, we've gone from the basic use of GPS to integrating sensors and being able to do all of it in one piece. It's very, very cool to learn about. So let's take a step back and talk about somebody who may be listening from outside the U.S. or maybe outside of agriculture. What are some elements within agriculture that you might know about that if somebody was looking for a job, those sectors in ag are really reaching for people right now, other than the technological side that we've talked about, that huge developing side? So
Yeah. Well, I think what I'd like to how I would like to start answering your question is by saying that agriculture is a very intensive science now. It's not the way people thought about it 50 years ago, where uh, knowledge was passed down from generation to generation. Sure, that happens, of course, today, but agriculture is a very intensive science. For example, genomics. We're breeding varieties of crops that now are producing 50% more yield than they were doing 30, 40 years ago, right? That's all people who study genetics. So there's a huge demand for people by the crop industry, the people who develop seeds, for people who understand genetics and can work with modern technology to advance the breeding process very quickly. 30 years ago, it would take 10 years to produce a new variety of a crop. Now, with the new technology that we have with DNA and GNA, understanding how DNA can help us understand the traits that we're trying to breed for, we can speed that up to 3 years. So just imagine that, as our world changes, as our climate changes, that we can develop new varieties very quickly that are adapted to the new conditions that we may encounter.
That's that's very, very fast compared to previously. So as far as somebody wanting to choose their major, and wanting to pursue a career, um, considering agriculture is advancing so fast, if I was to choose a major to help agriculture in its rapid development, what would be the best avenue for me to choose to help it develop faster?
Yeah, that's a difficult question to answer because, of course, people's interests are different. But
Right.
agriculture requires expertise all across the spectrum. So, from personal experience that agriculture is a business, and so we need very smart people to be in the business sector of agriculture so that we can better market our commodities, make better decisions about how to invest in agriculture. We have on the other end the technology that we've talked about. So, going into any kind of engineering and then wanting to apply that to agriculture is a great career for the future. But also understanding the fundamental agronomy, because as our world changes, as our climate changes, we will need to develop new techniques to be able to grow crops and feed the human population as it grows on this planet. So pretty much any sector of science, whether it's the hard sciences, the social sciences, or the soft sciences, applies to agriculture. But with the focus on ag, I think there are increasing job opportunities.
I believe so too. That's why I pursued this field, because I saw it as a way for me to have a wide variety of job opportunities and be able to pick from that. Because as far as ag goes, you can go so many different directions and get the same outcome. You get to work with in the field normally, or with people that are working in the field, and you get to enjoy the agricultural production side of it and maybe not directly in the farming side. So I think that's something that I enjoyed that a lot of people that may not understand that could enjoy also. So
Let me follow up on that point, and I don't know the numbers exactly, but let's say in our state of Georgia, we've got a few thousand people working directly on the farm, right, producing the food. But we've got hundreds of thousands of people behind them that are taking that food, processing it, and getting it to the consumer. So yeah, the ag industry is an upside down pyramid in terms of who produces the food versus all the other people in getting the food delivered and processed and stored and everything else.
right, that's equally as important, if not more important, getting it from the farmer to the table.
Yes, that's right.
That's very cool. So um, you mentioned before we talked that you have some upcoming events that are happening within the Institute of Precision Ag. Would you mind explaining what those are? Um,
Our first event, that's just a week or so away from us, is our second Integrated Precision Agriculture Conference. This conference will take place in Perry, in the state of Georgia. And the focus of the conference is to link the institute that we've been talking about to a new venture that UGA is embarking on called the UGA Grand Farm. The Grand Farm is a 250-acre farm in the heart of Georgia, where we will be attracting startup and established companies to test new agricultural products, primarily technology products, in a place where they can work together with the researchers and graduate students to advance this technology and bring it to market faster than before.
That's super cool. What, if you can share, what type of technologies might they be trying? What is
So the technologies vary. I can't speak specifically about companies, but I can tell
Right.
you the breadth. So, for example, there are companies that are producing soil additives that enhance the interaction between the plants and the biosphere, the bacteria and other microorganisms that live in the soil to make nutrients more available to plants so plants can more efficiently use those nutrients. And on the other hand, we have companies that are working on sensors that you can attach to a plant leaf and be able to use that as a sentinel to know when the plant is under any kind of stress. So you get the signal before you can see anything visibly with your naked eye, and you can go to the field and start to diagnose what might be happening in the field and prevent widespread spread of a disease, for example, in your field.
That's incredible. So, if if you were somebody listening to this podcast, let's say you're from out of the U.S. And you're wanting to get in touch with uh, a agricultural person in the U.S. trying to learn and be educated more on these topics, where might you lead somebody to?
So if you were, let's say, a farmer in another country that was growing a crop that is also grown in the U.S., and you had some questions about what's going on with your crop, you could easily go to the University of Georgia Extension website, where colleagues have developed very good information about all kinds of problems that you might encounter with your crop and the solutions that solve those problems. And all that information now is available as a PDF document, so you could easily download that information. So that would help diagnose problems and solve issues that you might be encountering. If, on the other hand, you're interested in studying in the US and learning more about these things that we've talked about, my suggestion is to look at university websites and identify a researcher who's doing the kind of work that you might be interested in and contact them directly and see if there's an opportunity to work together. But there are lots of opportunities for us here in the US to interact with our colleagues and our friends all over the world to solve all these challenges that everybody is facing. It's not just people in the US, it's farmers all across the world that are encountering the same challenges.
That's very true. Thank you, Dr. Vellidis, for coming on today. I appreciate your insight on this and coming and talking and being the first guest of the podcast. I thank you for coming along and talking about these concerns and issues and developments within ag. I appreciate you doing that.
It's my pleasure, John. Thank you for inviting me, and I look forward to listening to your other podcast.
Yes, sir. Thank you. Appreciate it. All right. Goodbye.